Hello, everybody. My name is Muhammad Mas Khan, and my teammate is Fiza Zishan. The topic of our presentation is what are the benefits and drawbacks of streams in Java. So, let's get right into it. So, let's have a quick look at its history. Well, the latest version of Java, called Java 8, was released in March 2014, which introduced features that would change the way you program on a day-to-day basis. Java 8 adds a new API called Streams API. API here is an acronym for Application Programming Interface. Now let's see write data processing readable code, which can be defined as a sequence of elements from a source. To process data more simply, the Streams API supports many built-in operations. It also allows us to process data in an even more declarative way.
Hello, everybody. So, I am Fiza, and today I will explain what exactly are streams in Java. A stream is an abstraction of, in some order, a mutable set of data-type functions. Or, in other words, if the value can change, the object is mutable, while if the value cannot change, the object is called immutable. And streams are non-mutable. An abstraction roughly means it's a general idea rather than a specific thing. Java 8 Streams is a framework to allow us to process sequences of our own objects and treat them using ways more commonly found in functional programming. The abstractions here are the things that go in the stream and the operations you can invest to apply to every object in that stream. So it is necessary to know that Java 8 streams are formed in a way that a stream is returned by the stream operations. This in turn will assist us to build a chain of stream operations as programmers. Okay, so in java.util.stream represents a stream that can be used to perform one or more operations. Streams has two kinds of operations that are either terminal or intermediate. Intermediate tasks return a stream so that various intermediate options can be combined, whereas terminal operations are either empty or return a result that is non-stream. Okay, so here we have examples of intermediate and terminal operations. Let's go through some intermediate operations. First up, we have filter. This returns a new stream containing some of the components that were original. The elements that should be restored are determined and the rest are discarded. So map. A stream.map in Java 8 helps us to transform an object to something else. So we have the specific code, an example, which is items.stream.map. This example maps all strings to their uppercase equivalents in the set of objects. Okay, so next up we have sorted. It is an intermediate stateful operation that returns a new source and it provides the default sorting. So now we have some terminal operations. So first up we have for each. The for each loop in Java is used to iterate via array and collection elements like ArrayList. It is also known as the strengthen loop. And then we have collections. Streams support aggregate operations on collections. The aggregate operations allows us to demonstrate repeated stream operations easily and accurately. For instance, we need to type java.util collection in our IDE. An example of an IDE is in IntelliJ to use collections like a filter or set to build streams on a source. We will go through their code later in the presentation. First, we will list all the benefits and drawbacks of streams in Java.
Why are Java streams so popular these days? Probably because they offer numerous benefits. Let's go over some benefits in this slide. So, first up, we have functionality. So, functionality, we can say that streams have a good functional affinity. Streams, as in streams offer the most simple and natural way of adding features to object sequences. And then next up, we have mutability. So streams facilitate lower mutability, which means that you don't need to change objects when writing a code using streams. And then we have looser coupling mechanism. Well, first of all, let's go over what loose coupling is. Loose coupling is when classes are mostly independent of each other. If the only knowledge that class A has about class B is what class B has exposed through its interface, then class A and class B are said to be loosely coupled. To make it more simpler, we could say that if you change your shirt and you are not forced to change your body, um, well, when you can do that, then you have loose coupling. But when you can't, then that's tight coupling. Like if you change your shirt, then you're also forced to change your body. So that's tight coupling. So a looser coupling mechanism in streams means that streams enable us to have a looser coupling mechanism. There is no need to recognize the source of the stream or its eventual halting method for your stream handling code. However, even these helpful and popular streams have drawbacks that must be addressed. You can see some of the drawbacks listed here. Let me elaborate on them. So first up is performance. In Stream API, there are a lot of methods, and so the overloaded methods are the most confusing part. This means that the learning curve, of course, takes a lot of time. Yeah, so in a way, you could say it's time consuming at first. Um, then there's familiarity. So in some environments, you want to write code that's familiar to special kinds of users, such as those who do not have any prior knowledge about streams. Also, then you can see comes reusability. So streams are traversable only once. So if you traverse the stream once, it is said to be consumed. To traverse it again, you have to get a new stream from the source code.
Okay, so now let's go through some code examples of intermediate operations. First, we have filter. So filter returns a new stream containing a sum of the original components. In this example, we have a list of integers. We have to find elements that are divisible by 5. So we use this specific line, which is a list.stream.filter, to filter all the numbers which are divisible by 5. Okay, so just by using this single line, the filter function and the modulus operator, in this one line of code, we can find all the elements that are divisible by 5. If we run this code in the console in IntelliJ, we will get 20 as an output, since 20 is the only number in this list which is divisible by 5. Okay, so here we have a map. So map helps us to transform an object into something else. So here we have a simple print statement, then a list of integers. So map function is used here to transform this specific list to something else. We will multiply each number in the list by 3 using the stream.map function. So we used this single line, which is list.stream.map, to multiply each number by 3. So the output after using the stream function will be the stream after applying the function is this line is displayed as an output because we used a print line function here, and these numbers 9, 18, 27, 36 and 45. Okay, so now let's have a look at the sorted function. Okay, so sorted is a stateful operation that returns a new source. Again, we have a list of integers here with both positive and negative numbers. Then we have a print statement here which states the sorted stream is and a colon. We will sort the list in ascending order here by using list.stream.sorted function and the for each part, a for each loop. So the output will be the sorted stream is -18, -9, 0, 4 and 25. All the numbers are sorted in ascending order here.
In this slide, I would like to go over some code examples, and these coding examples include terminal operations. And these terminal operations in turn include the for each loop and collections. So I will explain the collections part later, but for now let's just dive into the for each loop. So let's just get started. Um, as you can see, the for each loop uses hash map. But first, let me explain what hash map is. Hash map is a map-based collection class that is used for storing key and value pairs. So, in the following code, a mapping is created between keys and values. As we can clearly see, all the keys and values have been linked together using map.put, and then in parentheses and in double quotes a, comma, and in double quotes again Alex. And then the same has been done for Brian and Charles with their respective keys as B and C. So after that, of course, you can see that we do not forget the semicolon because it is necessary to use the semicolon as we tell Java that way that we're done with that part of the code. And then, of course, we move on to map.forEach. So this will initiate the for each loop. And then, of course, in parentheses, we write kv to specify the keys and values. And then, of course, you can see system.out.println function being used, which asks Java to print the output. The output after using the for loop will be key equals to A, and comma value equals to Alex because we write that in the system.out.println parentheses. As I said before, I'd be going over the collections code after the for each loop code. So here I will be comparing collections with streams. So let's just look at the collections code first, and then we can move on to streams. So in the collections code, you can see an array list being created with the name of laptop list. And in that list, we can see various brands of laptops being added in. After that, to sort those in an alphabetical order, collection.sort, and then in parentheses, laptop list has been written. And then the for loop is used to print out all the names in the list. These will, of course, be printed out and sorted automatically, alphabetically, because of the sort command. And then now moving on to the streams code. Well, the streams code has basically the same thing. It has the same code, but but you can see the minor difference here is that the complicated long code is decreased to the code you can see after the adding item in the array list. Both of these codes will of course have the same output. But as you can see, the streams code is a bit shorter and it seems much easier on the eye. So now while we're on this slide, I'd like to go over some benefits and drawbacks of using streams and collections. So some benefits and drawbacks of streams when compared with collections could be that collections are used in a specific data structure like list, set, or map to store and group the data. However, streams are used on stored data such as arrays, collections, or input-output resources to perform complex data processing operations such as filtering, matching, mapping, etc. That means collections are mainly about data and streams are largely about data operations. Elements can be added to or removed from collections, but you can't add elements to streams or remove them. Streams uses a source, performs an operation on it, and returns the outcome. Streams also do not modify the source. The main best feature of Java 8 is that while using streams, you do not need to worry about iteration. Streams performs iterations for you behind the scene internally. All you have to do is mention the processes to be performed on a source. On the other hand, you have to do iteration externally over collections using loops.
Okay, so here I would like to talk about the major differences between using for loops and streams from the code's efficiency and long-term maintenance point of view. First, I will explain both codes. Okay, so we have a list of integers. The array is filled with random integers. We will double and triple the values stored in the array. Okay, so on one side, here is a traditional solution using a for loop. Here we have a for loop, double and triple numbers which will be stored in different arrays using a single loop. And on the other side, we have an array with numbers, and we can apply the doubling and tripling within the stream. Okay, so now a for loop through an array is super durable and respect to heap and processor use. Using a stream is even worse if raw memory speed and thriftness are a necessity. For loops win by pure performance, so they are more efficient and they win by pure performance. Okay, so streams encourage less mutability. A for loop has a lot of lines where streams can be implemented by using only 1 to 2 lines of code, which makes the code easier to read and understand. This means that the streams are easier to read, so they win by readability. So this is a benefit of using streams in Java. Okay, so these days debuggers are growing, but right now as you work through stream code in a debugger, it can be more difficult to run than the equivalent loop, as a simple loop is very similar to the variables and code positions than a standard debugger deals with. Here we have inserted some references. And that brings us to an end, so thank you for watching.